In this video, we'll be looking at right triangle word problems and triangle area. So often in these word problems, we're going to have vocabulary that we haven't seen before, so we need to go through that first. We have seen standard position throughout our look at trigonometry so far. And remember, that just means if you have a coordinate plane here, standard position means your terminal side rotating counterclockwise is positive and clockwise is negative. That's all that means. So this is an angle in standard position. Now, in these word problems, we're going to see other things. So, for example, angle of elevation, that's a measure with respect to a horizontal line. So if we have an angle like this, this would be the angle of elevation right here. Angle of elevation. So what is that angle between this horizontal and the ending side right here? So that would be an angle of elevation. All right, angle of depression is similar. So the horizontal is here, write that in, horizontal, and the angle of depression would go down this way. So if we measure this angle like this, and we could label this theta, but this would be an angle of depression example. Notice depression, you're starting from the horizontal and going down this way. With elevation, you're starting with the horizontal and going up this way. All right, next vocabulary, navigational angle. So in some of these problems, they'll be discussing navigation, so of a ship or a plane, something like that. And we measure with respect to due north, and positive is clockwise there. So if we call this due north like this, and we have another line over here like this, and we call this would be, for example, 240 degrees, that's how navigational angles are measured. So we start due north, and positive is clockwise. So that's different than standard position where we go counterclockwise for positive. So you need to get used to these various types of measurement. Next, we have surveying, a bearing angle, and it's the acute angle, so less than 90 degrees, at which the direction varies to the east or west from the north-south line. So we'll draw a north-south line in here like this and label it. So north is up here, south is down here, and we have our center point between north and south. So we'll put that in like this, and this would be west, and this would be east. So then when we put lines in here, so for example this one, and we measure always off the north-south, so we're measuring off of this line. We never measure off the east-west line, okay? So with this one, let's say this angle was 30 degrees, for example. Then this angle would be specified as north 30 degrees east. So you always list either north or south first, then the measure of the angle, and then the east-west direction. So let's put a line there. Let's say we have one down here, and we always measure off of the north-south line, so we'd measure right here, and let's say that's 10 degrees. Then this one would be specified as south 10 degrees east, like that, south 10 degrees east. And over here in this quadrant, let's say we had this line like this, we always measure off the north-south line. So let's say that angle is 70 degrees. Then this one would be specified as south 70 degrees west. So always north-south first, then the angle measure, then east-west. Okay, last example, we're up here in this section. Always measure off north-south, so we're going to call that 45 degrees. So this one would be specified as north 45 degrees west. Okay, next section here, the area of a right triangle is given by area equals 1/2 base times height, or as I like to usually write it, base times height over 2, same thing. And if we're using our standard naming of triangles, so if we have a right triangle like this, and this is A, B, and C, so this would be, this is a capital C there. So this would be little b here and little a there. Then the formula becomes little a times little b all over 2. It's the same thing as base times height. It's just that a in this case is our height and b is our base. So example 1, from a point 384 feet in a horizontal line from the base of a building. All right, so we've got a building here. And we are, this dimension right here is 384 feet. The angle of elevation to the top of the building, so that would be this one, is 36 degrees and 22 minutes. So how tall is the building? So we want this dimension right here. How tall is this building right here? So we'll say the height. That's what we're looking for right there. So we have this dimension here, we have this dimension here, and we have this angle right here. So the first thing that we can do is convert 36 degrees 22 minutes into decimal degrees, and we've used our calculator for that before, so we're going to do that now. You could manually convert it, but we'll use our calculator to do that. So I'm going to make sure I'm in degree mode. So 36 second apps is the angle menu, 36 degrees, and 22 minutes, second apps. Option 2 is the minutes button. So there's my 36. We'll round it to 36.37 degrees. So I'm going to write that here, 36.37 degrees. Minimize this. We'll need our calculator again. So from this angle of 36.37 degrees rounded, we have the adjacent side and we want the opposite side. So that's tangent that we need to use. So tangent of 36.37 degrees is equal to the opposite side, I'm going to call that h, over the adjacent side, 384. So the height that we want is equal to 384 times tangent of 36.37 degrees. I know my calculator's in degree mode already, so I just type this in, 36.37, and we get 282, we'll round to one decimal place, so 282.8 feet. So this is 282.8 feet. And that's it for example 1. All right, example 2. Find the area of a parcel of land whose boundaries are marked as follows. Beginning at the old oak tree, thence 402 feet south. All right, so we'll make a dot here. We'll call this the old oak tree. And we go 402 feet south, so that would be this direction. So this is 402 feet there. Thence 464 feet north, 30.1666 degrees east. Okay, so north and east would be back this way. So this is north and east is over here. So that measure would be like this. And thence due west back to the old oak tree, so like this right here. So this is the 464 feet length. And this angle inside here is the 30, I'm going to write it out here, theta. So theta is equal to 30.1666 degrees. Okay, so we want the area. So we need the base and the height of this triangle. If this is our right angle, obviously here, so we need this length first. So we can use Pythagorean theorem or we can use our trig functions. It doesn't matter which. I'll just use the Pythagorean theorem. That would be fine. So I'm going to call this side B for the base. So B is equal to the square root of 464 squared minus 402 squared. So that length is equal to, type that in our calculator here, and we get 231.7 feet. 231.7. Write that here, and that is in feet. So we want the area. That's what they asked us for in the beginning. We want the area. So that would be the base, 231.7, times the height of the triangle, which would be the 402, all over 2. So I'll use my fraction button here. Let's get out of that. Try that again. There we go. So 231.7 times 402 in the numerator, all over 2. And we get 46,571. 46,571.7, and that would be, because the dimensions are in feet, the area would be feet squared, so square feet. So 46,571.7 square feet. So that's it for this example, and that's it for this lesson.